Hello coders, welcome to my channel. I am Aniket and today we will be discussing the problem subarray frequency count queries from GFG. Let's read the problem first. Given an array of n integers and a 2D array queries representing q queries where queries I consisting of three integers l, r and x. For each query, determine how many times the element x appears in the array from index L to R, both inclusive. Return a list of integers where ith value represent the answer to the ith query. Let's do the same in this test case and see how this test case answer will be generated. So in this case, as you can see, the first query is 0 to 4. So 0 to 4, 1, let's indexing it 1, 0, 1, 2, 3, 4, 5 and 6. So how many times in 0 to 4 1 is occurring? So 0 to 4, this range 1 is occurring 3 times. So the answer to this query is 3. And similarly, how many times 2 to 5 2 is occurring? So 2 to 5 2 is occurring only one time. So answer to this query is only 1. And how many times 3 is occurring in the range 1 to 6? So 1 to 6, if we see 1 to 6, then how many times 3 is occurring? 3 is occurring 2 times. So answer to this query is 2. And how many times 0 to 6, 5 is occurring? So if we take the whole range 0 to 6, how many times 5 is occurring? So in this case, 5 is occurring, 5 is not occurring in the array. So answer to this query is 0. So you have to return the answer list which is containing the answer of each query. So in this list, the entries are 3, 1, 2 and 0 and you have to return this list. I hope you got this question. Let's jump to its brute force method. How can you do it? So as you can see, you are given a L and R, then you can simply go to L to R for each query. So let's say there are q queries, then you traverse the array L to R to answer that query. So this is the brute force method. For each query, you go to L to R and count the number of occurrences of that X element. So in this case, what happen if L to R is L to R is the whole array? What happen when L to R is whole array? Like L is 0 and R is 6. What happened to this? Then the range will become is equal to n, and your for each query you go to n, so the complexity will become q into n in worst cases. In worst cases. So let's say q is lesser than equal to 10 raised to the power 5 and n is lesser than equal to 10 raised to the power 5. So the number of operations required in this brute force approach is 10 raised to the power 10, which is greater than 10 raised to the power 8 operations. So you can't do this in brute force way, because in this brute force way will give you TLE. This brute force will give you TLE. Let's discuss its optimized way. How can we optimize it? Let's discuss its optimized way. What is the optimization? So for optimization, we can use a map. Use a map where the key is array of I and the value is list of indices where array of I is present. So for this array, what is the how can you populate this map? So as you can see, 1 is occurring at 0. So initially 1 is not having any array list, so you have to initialize a array list first. Then 1 is occurring at 0 index, so you put 0 corresponding to key 1. Then 2 is uh, coming, then you do 2 to, because its first index is 1, so you store 1 index to the key 2, because key is representing array of I. Similarly 1 is again coming, so you don't need to make a new key of 1, because 1 is already present here, so you will add 2 to 0. So 1 is presenting 0 and 2, as you can see here also. Similarly 3 is occurring, so you will do 3 to 3 index. Similarly 1 is occurring at 4th index, so you will add 4 to this list. Similarly uh, 2 is occurring, so you will add 5 with 1. Similarly 3 is occurring, you will add 6 with 3. So this is the map that you can easily make using this array. So how can you use this map for answering each query? So let's see. Now the question becomes, how many indices is present in the range L to R? So how can you answer to this question? Because you have a list of indices, as you can see, for each key array of I, you have list of indices where array of I is present. Now this map can help you to find to get the list of indices. In this using this list of indices, you have to find the occurrence of that element from L to R. So the approach to this is, we find the first occurrence of element or indices. We find the first occurrence of indices where the greater than equal to L is occurred. We find the first occurrence of indices where greater than equal to L is occur, and we find the last occurrence of indices where lesser than equal to R occurs. What is this L and R? It is specifying in your query, because query is of the form of X, L and R. So I hope you got this. We find the first occurrence of indices where greater than equal to L occurs, and we find the last occurrence of indices where lesser than equal to R occurs. Since the list is sorted because you traverse the array from left to right. That's why your index will be sorted. So list is sorted. Let's see this method, these conditions, and apply this on one query. Where that query? Let's see, we apply this here, 041. Let's see, we have a query 0, 4 and 1, and the map will generate this type. So 1 will giving you 0 to 4 and 2 will giving you 1 and 5 list and 3 will giving you 3 and 6. So the value you found in the range 0 to 4 is 1. So call map dot get R minus L plus 1. We will consider it R1 and L1. That is the index we got from other function. That is R1 and L1 plus R1 minus L1 plus 1. Let's see it with other query also. Here as you can see, there is this query 2 and 5 with value 2. So you will call your map 2. So if you call map.get 2, you will get this list, and if you get this list, then you simply call first occurrence of where greater than equal to 2 is occur. So where this is the first occurrence where greater than equal to 2 is occur. Is this that occurrence? No. Is this? Yes. Here the greater than equal to 2 is occurs. So its index is 1, and similarly you will call lesser than equal to 5 occurs. Last index. Here lesser than equal to 5 is it? Yes, but not last index. So the L1 R1 value is so if you do R1 minus L2 plus 1, then the answer L1 is 2 and R1 is 1. 1 minus 2 will give you 1 and minus 1 plus 1 will giving you 0. What about when the R1 is here also? So in that case L1 is greater than R1, so that is not the case. This is not feasible that L1 is greater than equal to R1. So in those cases you have to print for answer ID equal to 0. I hope you got this. Why you consider 0? Because here you can't find 3 to 3. In the range 3 to 3 you can't find anyone. That's why you will do the you will answer to this query is 1 0. I hope you got this. Now the question arises, how can we find L1 and R1? How can we find L1 and R1? So answer to this question is binary search. We can use binary search. Why? Because our list of indices is sorted. That's why we can use binary search to find L1 and R1 and simply return our answer to each query. Let's see our code now, which follows this intuition same as above. So here is my code. First, I initialize array.length and creates a map which stores array I as a key and a list of integer which is denoting the list of indices where array I is present. I discussed in the above in the previous section. So you will populate this map according to this. If then key is not present, initialize a new array list corresponding to that. If it is present, then we simply add that index to that key. So, and this will create that map. This will create this type of map. I hope you got this. This will create this type of map. So after getting this type of map, then you go to this queue will store the query.length and answer is storing the answer to each query. So first you will initialize the id equal to 0. There is no need of this statement. It is list. So you go to the each query and process each query one by one. Then if that is not present to your map, then you can't find any occurrence of that value into your array. So that's why you will simply add 0 to your answer and continue to other query. If it is present, if that key is present, x is present in your map, then you simply get the map.get x into your list and this will give you the list where that value is present. This will give you the list of places where that value is present. Then simply you will get L1 and R1 from this bin1 and bin2 function, and if that L1 and R1 is equal to 1 or L1 is greater than R1, then you simply add 0 and continue to other query. Otherwise you will add R1 minus L1 plus 1 to your answer and simply return your answer. Let's see bin1 operation, bin1 function and bin2 function. We will see it with an cascade diagram so that it will visualize it better. Let's take the query 041. In this case, you will got the list as 0 to 4 when you call the map.get x. So you will got this list 0 to 4. Then you simply initialize your L pointer to the 0th index, that is this, and you will initialize your R pointer to the list of 5 minus 1, that is this. This L and R is not the same as the query L and R. It is different because it is initializing in different function. So while L is lesser than equal to R, you will do this same. First you will find the mid. In this case the mid is this. So we will find the mid, and if mid is greater than equal to target, here in this case the target bin1 function is used to find L1 and bin to function is used to find the so in this case target is equal to L. What is the target? So target is 0 in this case for bin one function. So is 0 is greater than equal is mid, that is 2. 2 is greater than equal to 0. Yes, 2 is greater than equal to 0. So you will initialize id equal to the mid. What is mid? Mid is the initial of the index where I is 0, 1 and 2. So mid is 1. So id equal to 1 and you will go r to mid minus 1. Now the r will become 2 minus 1. Now the new r will be this. Here in this case, you will go to the loop again. Is L is lesser than equal to R? Yes. So you will calculate mid again. In this case, mid is equal to 0 because L and R both 0. So 0 plus 0 going to give you 0. So list dot get mid is greater than equal to R. Is this condition hold? So list dot get mid is 0 and 0 is greater than equal to target. Target is 0. Yes, 0 is greater than equal to target. So you will update your id to mid. What is mid? Mid is 0. So your id will become 0 and next time your r will go to mid minus 1. Now your r will point to this. Now r value is minus 1. If you carefully see, L is lesser than equal to R is not holding because L is 0 and R is minus 1. So this you will break out of this loop and simply return your ID. What is your ID? ID will store the index 0. So this in this way you will find your value L1. Let's see how can you find the value R1. R1 is in this case the target R is 4. This way. This is the target 0, 4, 1. This is the R. And you want to find R1. So you will here the target is 4 according to the test case. Then you simply do 0, 2, 4 indexing 0, 1, 2 and L is initially at 0 index. R is initially at the last index, that is this. Then we will simply find the mid. Mid is this. Then you will do check this condition list dot get mid is lesser than equal to target. So list dot get mid is 2. So 2 is lesser than equal to target. Target is 4. Yes, 2 is lesser than equal to target. So what you will do? You will store id to that mid, that is 1 and go to the L is equal to L mid plus 1. Now L will go to this mid plus 1. Now both L and R pointing to same, so mid will be pointing here also. So all of them are pointing this index. So if you calculating your mid, now mid will become 2. So list dot get mid is lesser than equal to target. Yes, 4 is lesser than equal to 4. That's why you will update your ID to 2 and L is equal to mid plus 1. So L will go to next index. Now L will point here. So the L value will be 3. Now this condition will not hold because L is 3 and R is 2. So L is lesser than equal to R is not holding. That's why you break out of this loop and simply return your ID as your answer. Now in the above you will find L1. L1 is 0 and in this function you will find R1. R1 is 2. So if you do this operation, because here R1 is greater than L1, so you will do this operation R1 minus L1 plus 1, which will give you 3. So answer to this query is 3. I hope you got this. Let's discuss its complexity now. Since you create a map by while traversing the array, this will give you O of n complexity. Then you go to each query O of q, and for each query you will simply do a binary search on the list of indices In worst cases, those list of indices can be equal to the uh, array length. So in worst cases, you will search log n, because this n will represent the size of the array. In worst cases, the list of indices can be stored, and you will find this with a binary search. So binary search complexity is log n. So for each query, you will do q into log n. So what is the complexity to this approach? You will do n operation above, so n plus you will do q into log n operation here, so q into log n. This is the complexity, and this will accepted solution, because it is under 10 raised to the power 8 operations. I hope you got my code and intuition behind that code. Please like and subscribe my video. Thank you for watching my video.